In this webinar, we'll outline firstly what we mean by cloud computing, then we'll explore what the implications are for what the implications of the adoption of cloud as an IT operating model and functionality consumption mode are for security, and make a distinction in terms of requirements between facilitating the use of external resources using internal logic or security for the cloud, and security for a shared elastic resource residing in a third-party environment or in a dedicated private cloud. That is security in the cloud. To some extent, we can understand security in the cloud as applying policies to a workload to enable elasticity in its purest articulation. The point of commonality between the two security modes, if you will, is policy, an idea we'll dig into later. Security for the cloud can be understood as a bridge or federation, more technically, between on-premise and off-premise infrastructure. Typically, we're speaking about SaaS here, putting aside for a moment the ongoing debate on whether SaaS is truly cloud. Increasingly, we see the need for security in the PaaS and infrastructure as a service environments through the mechanisms of identity management, access control, and flow-based enforcement for uses like cloud bursting or to serve the business need to bring up and down applications with a consistent set of policies in place, be that dealing with a particular set of partners, be it dealing with a particularly congested time of the year when there's peak use of resources. Private clouds could be viewed as the most prevalent example of the target for security in the cloud, where infrastructure, application, and data reside in a third-party service. And we'll delve into more into adoption trends a little later on, and why, and explain why private clouds are the tip of the spear. In terms of long-term and technology adoption trends, we also see security for the cloud as a means of securely facilitating hybridization, which is the term we use to describe the mix of on-premise and off-premise resources to leverage the cloud's benefits and still maintain the integrity and coherence of internal processes, as well as security policies. Hybridization also leads to technologies that will likely straddle security for the cloud and in the cloud for some time, especially as security becomes embedded in cloud services infrastructure. So we think of the distinction between security for the cloud and security in the cloud is an important one to make, since it brings some degree of clarity to an issue that's been framed in pretty dramatic and potentially overhyped terms. That's not to say that security is not crucial to appropriate and efficient use of cloud-based services. We as a firm view cloud computing as the logical endpoint of a convergence of technologies that started back in the days of grid and utility computing, and then picked up pace with virtualization, and then the second coming of ASPs, generally now known as SaaS. Although obviously there are architectural distinctions between those two technology types. Up until now, security is served to define what cannot be performed in the cloud, or what functionality cannot be consumed as a service using internal logic. Again, that's what we refer to as security for the cloud. Certainly the picture has been obscured by the fact that the cloud does prevent a novel consumption model. And as a result, there's been some degree of uncertainty on where the ultimate responsibility for security lies. And just as by way of explanation, we see the infrastructure logging and reporting capabilities required for compliance as a subset of security infrastructure. So when I talk about security, I'm including compliance too. But turning back to cloud as a novel consumption model, essentially what's emerged in this tug of war is a new touch point that we refer to as a cloud edge. They can either be represented by a gateway between an incoming services provisioning request and an outgoing services response, as well as a threshold against which internal policies and external functionality traverse. We believe over time that cloud providers will assume more of the responsibility for the operational transactional security of their services, in addition to providing infrastructure integrity and protecting the actual the infrastructure that's provided as a service. Particularly implementing data security and managing access to the database tier in a more systematic way. And we see this driven by pragmatic business reasons like competitive differentiation or competitive advantage, and also the need to increase adoption, broaden adoption by providing data security, by providing administrative user oversight, and providing some assurance of the existence of infrastructure integrity. But the policy, who has access to which data, with what rights, within which context, within which business process, and within the application flow, should remain the organization's responsibility. In practical terms, expect that the lines will frequently cross, and in most instances won't be drawn clearly, but the point is that security control shifts high in the stack and increasingly brings policy into central focus. To some degree, technology like encryption doesn't change its core functionality, but how it's delivered and managed shifts dramatically. Policy becomes a real nub here, and by extension, engineering consistent enforcement is a major challenge. So, what are the technology distinctions in security in the cloud and security for the cloud, and what are the requirements that flow from it? At a high level, distinction involves being able to extend control to a third-party resource, and this typically involves access policies, reporting and logging, and identity management SaaS applications. We'll look at federated single sign-on to SaaS as an example later in the webinar. In the second instance, security in the cloud involves the ability to transpose policies onto a shared elastic resource in a dynamic, virtualized fashion. So rather than exploit corporate infrastructure to monitor and enforce policies like domain-based access controls, directory logic, or firewall access control lists, security in the cloud entails a services-based enforcement model with visibility into the workload and its association with an identity, and we see identity becoming a broader context, expanding beyond user profile to include service, application, or system entity. We've certainly seen some organizations build cloud VPNs almost from scratch to resolve many of the issues we see here in terms of data security, compliance, and access controls. But the question becomes one of scale. For service providers, the challenge is to move up the stack and provide the security ability to meet compliance requirements and a way to dynamically associate policy with sessions at the infrastructure level. From a networking perspective, we can talk about session persistency as a primary challenge. But from a security perspective, we have to think about policy persistence along with session persistence. Some of this involves migrating security infrastructure into the cloud, but in order to achieve elasticity and support dynamic enforcement models, IDS, IPS, and identity management need to operate as load-balanced virtualized instances that get spun up and spun down as sessions are created and terminated in the cloud. We need to be cognizant that security in the corporate network sense doesn't apply anymore. Yes, we have firewalls at the perimeter, but the integrity of the service is now a common resource. Instead, we need to understand how to secure a transaction and the data encapsulated by the transaction, with policy providing a heartbeat and logic for enforcement. And we'll delve into the architectural challenges a little later. So how do we define cloud and inject some specificity into our discussion? The following slides are drawn from our Cloud Codex framework, which we developed as a firm about 9 months ago to frame the discussion of cloud. First of all, we need to point out that cloud needs to be understood in horizontal and vertical dimensions. Horizontal in the sense that are types of clouds that exist along the spectrum, from public to what referred to some as private. They can also be understood as dedicated. The various types of clouds exist along a continuum called the cloud spectrum. This continuum charts the progression of clouds on several axes, moving from closed private clouds to commodity clouds with several flavors in between. And then the vertical gradations exist along the traditional IT stack, i.e. software as a service, platform as a service, and infrastructure as a service. And at this stage in the market's development, these borders are more idealized than actual, and the borders are less than concrete. In fact, there are more variations and vagueness in the model than we'd like, but that reflects an evolving cloud landscape, which makes classification less exact. So we define 8 primary criteria that together constitute an infrastructure cloud service. Each criterion can be evaluated on its own, and there's certainly gradations. Each criterion is not an all or nothing proposition. However, each criterion builds on the one before, and there are clear dependencies, with certain cloud properties being difficult to architect without appropriate supporting attributes. An absolute requirement for any true cloud computing offering is multi-tenancy. And multi-tenancy is the ability to support not only multiple users on a single complex of servers and storage, but also multiple organization units and multiple logical groupings of computing and storage abilities assigned to various users and organizations with policies applied to them.